Okay, in this tutorial, I'm going to show you how to conduct or calculate the range of a data set, the interquartile range of a data set, and also how to then present your data visually using what's known as a box and whisker graph. As I go through each of these steps, you should complete them yourself, and I'll also help you answer all of the different questions that go with these skills. Now, the data set I have chosen to use here has come from a study that a group of students have done in Perth. And you can see up here that they have gone into two different housing areas, two very contrasting housing areas. And in those two areas, they have visited 16 locations. And we can see here those 16 locations. Now, those would have been selected using some kind of sampling strategy and would probably been spread out across the area. At each of those locations, they have conducted an environmental quality study of the surrounding environment of that location. And they've used a bipolar scoring system to complete that study. So that's where you do the study with negative and positive scores depending on different environmental aspects. And you normally have a range of aspects that you would be scoring, for example, the amount of greenery, the amount of pollution, the amount of noise, the quality of the housing, all those kind of categories. And then you would make a judgment about whether it was positive or negative, and 0 allows you to give a neutral score. So in area 1, the worst area that they found had a -20 score. Now, it's possible to have got -30. That would have been if every area had scored on the worst category. Likewise, the best area is 21, and the best possible score that area 1 could have achieved would have been 30. That is if every category had scored the highest possible score. Okay. Now, what we can see here for area 1 is that we've got quite a big spread of data. The actual range itself, which is the difference between the highest and the lowest value, is 41, and we can see this down here. Now, the way that was calculated was by doing a simple little sum, and we can see it up here. I've used the equal sign, which means I'm about to do a mathematical calculation. I've then selected the value that there was the highest, and I've just clicked into cell B18. There is cell B18. By clicking it, it automatically selects B18. I've then done the minus symbol, and then I take away the smallest value, which is -20, the lowest value. And I've clicked on that, which happens to be cell B3. And then I hit the return button on my keyboard, and it works out that calculation for me. So it tells me the range is 41. So I'm turning this spreadsheet into kind of like a calculator. Okay. Now, let's just stop and think about the range itself. Why is the range useful? And what is the range useful for in terms of the median? Now, you've already been shown how to calculate the median. We can see the formula up here for calculating the median. The range is the spread of data. Okay, it shows me how wide my data set is. There's all kinds of reasons you might want to know if a data set is very spread out. If it is a very wide data set with a very big spread from the highest to the lowest value, we'd call that a dispersed data set. It's a very dispersed data set. If all of the values were very similar to each other, and the range was therefore very small, we'd call that a clustered data set. Okay, so a very useful little statistic in its own right. It becomes even more useful if you work out the range of a second data set. So if we did the range for area 2, which you're going to be asked to calculate, we could then compare the data for area 1 and area 2, and we could then maybe speculate why there's a different range. If we know the median for these two data sets, that's also useful. So the median is the middle value. And by knowing the ranges, we can see how the data is spread around the median. So how is it spread above the median? Well, if 21 is my highest, I can see that there are 13 scores higher from 8 to 21. There's a difference of 13 there. Whereas if I look at the score from the median to the lowest, that's a difference of 28. So my data set for area 1 is spread towards the lower values. That means that the range is bigger on the lower end. There's a 28 between -20 and 8, and there's only 13 between 8 and 21, which is the highest value. I could do the same with my area 2. I could see how's it spread between the median for area 2 and the highest value, which would be 30, and the median and the lowest value would be -8. And I could see, therefore, is it spread towards the higher values or the lower? So I can start making some kind of descriptive statements about the spread of my data set. Here's the problem with the range. The problem with the range of a data set is it just takes one value to create a very different spread. And this data set here that you've already seen with the mean, median, and mode tasks shows you this problem. Slope A had 11 sites, and almost all of them, 10 of the 11, had very similar values, ranging from 22 to 29, which is a range of 7. So it's what I would call a very clustered data set. However, one of those sites had a substantially different value, moisture content, from all the others, 41. So actually, my range isn't 7, my range is 13, which is almost double. Okay, and I beg your pardon, it's not 13, it's 19, more than double. So this one figure here is giving me a very misleading description of my data. It's suggesting I've got a very spread data set because I've got a big range. And the reality is actually, no, most of my values are very clustered. So let's just have a little look at how interquartile range resolves that problem. Okay, so first thing you're going to have to do is calculate your interquartile range. And I can see that I've done it for area 1. So how did I get to this? How did I work out my interquartile range is 16.5? Well, let's just first of all describe what is the interquartile range. The interquartile range is the difference between the range of my middle 50% of values. Now, because I've got 16 values, working out the middle 50% is quite easy. The middle 50% would be removing the 4 lowest and the 4 highest, which is a total of 8 samples, and just looking at these middle 8 samples here. That's the middle 50% of this data set, and here we've got the middle 50% of values for my area 2. Interquartile range tells me actually what that range is. So to do that, I need to work out the value of my upper quartile and the value of my lower quartile. And if we have a little look here, if I click into the cell, you'll see the equation that I've typed to work out my upper quartile is equals, and I've written the word quartile, and I've then selected B3 colon B18, which is these values here. And then I've done a little comma, and then I've typed the number 3 because I want the third quartile, also known as the upper quartile. It's given me a value of 14.5. And if we actually have a look at that, 14.5 falls between the 14 and the 16, which is the cutoff between the bottom 4 and the middle. So there's my upper quartile value. My lower quartile value is very similar equation. I've got quartile equals quartile brackets B3 colon B18. This time I've done comma 1 because I want my lower quartile, and it's given me -2. And if we have a little look, where's that coming from? There's my 4th, there's my 5th value. This is the cutoff between my bottom 4 and my middle 8, and you can see that the -2 falling there. Right, to get the interquartile range itself, all I got to then do, if I click into this cell, it's the B21, which is the upper quartile, minus B22, which is the lower quartile. And it's basically 14.5 minus -2. And I get the interquartile range of 16.5. So what's the difference between the interquartile range and the range? Well, the range is the spread of data from the highest to the lowest in the entire data set. The interquartile range is just the spread of data of the middle 50. And what that does, and why we use interquartile range in geography, is it removes your extreme values that might be skewing your data set towards higher or towards lower. The interquartile range can do a little bit more than that, though. If I have a look at my 2 quartile numbers here and my median, I can see that the gap between my median and my upper quartile was 6.5. That's just where I've taken 8 from 14.5. That's 6.5. And if I look at the spread between my lower quartile, that's between 8 and -2. Well, that's 10. So what I can see is that my data is getting pulled towards the lower values because there's a spread of 10, whereas it's less towards the higher values. So this area here has got a tendency towards much lower values. Okay, so that's me describing the spread of data around the median value. Right, interquartile range becomes even more powerful, however, when I work out the interquartile range for this second data set. Because if my interquartile range number is smaller, okay, it means my data is more clustered than area A was. If my number here was larger, then my area B is more spread than area A. So having two data sets or multiple data sets will allow you to compare them to each other. Likewise, I can also see if area B, how the quartiles are arranged around the median. So whatever value I get here, let's say my median was 10 and my upper quartile was 25, that would be a spread of 15. That's the difference between 25 and 10. And my lower quartile was 5. Well, if my median was 10 and the lower quartile was 5, that's only a spread of 5. So on the lower end, there's a spread of 5. On the upper quartile end, there's 15. So my data is being far more spread towards the higher values, which basically just means I've got a lot more of values on the higher range than on the lower range in the lowest area of the data set. So interquartile range does that. You can have a look at the information sheet that goes with this, which you should find in the Google Classroom. And you are going to be asked, obviously, to tell me about what the range is, calculate the interquartile ranges, and then to compare the two data sets. And then the final question is to speculate why there might be a difference in environmental quality scores between these two areas. And that is a pure knowledge and understanding question, which is why might a housing area have a better environmental quality than another housing area? And there is a range of factors you could use to explain that. Finally, and the last task is for you to think about box and whisker. Now, a box and whisker is a visual representation of the interquartile range. It's like an interquartile range graph. Now, when you go and create your own box and whisker graph, you are going to select both area 1 and area 2 and all of these cells. But the first thing you're going to have to do is actually calculate these other cells. So once you've worked out the minimum value of area 2, which is actually, you can see that on the data set here, -5, and the maximum value is 30. Once you've also calculated the quartile 1, that's this result down here, and the quartile 3, which is this result here, you will then be able to create this. So go ahead and calculate them and type them in and then highlight these cells. At the moment, I'm just going to show you by doing a box and whisker for graph 1, but I would suggest you do it for area 1 and 2, because then the graphs will appear side by side and you can compare them. Next step is to click on the little graph button, which is insert a chart. Okay. Now it's going to default to a bar graph. What you want to do is click on the chart type, scroll down until you get to this graph here, which is known as candlestick charts. Okay. And that is a box and whisker. Okay. There's the box, there's the whisker. And down here it says area 1. Now, the only thing we're missing is we don't have any titles. So we need to edit this chart. Okay. And we need to go to customize and we need to give it a title. So we might call it something like box and whisker chart comparing the spread of data for area A and area B. Okay, there's my title. And if I had selected both of them, area A and B, when I was doing this, you would see another box and whisker appearing alongside this. Now, when it comes to analyzing this, the first thing is the bigger your whisker, the bigger the overall range. The whiskers represent the range, the difference between the highest and the lowest value. The box represents the interquartile range. So there's the upper quartile, there's the lower quartile. If your box is really small, it means you've got a clustered data set. If your box is very large, it means you've got a very spread data set. So once I had area 2 sitting next to this, I would very quickly be able to see is area 1 more clustered than area 2. A clustered data set, by the way, just means you've got lots of values that are very similar to each other in the middle of your data set. A dispersed data set means that most of your values in your middle 50 are very different from each other. They're quite spread out. The second part, obviously, is the whisker. So if you've got very big whiskers, you've got a very large range. And if you've got small whiskers, you've got a small range. One final thing you can do is you will see here my whiskers bigger for area 1 than it on the on the bottom quartile than it is on the higher quartile, which means my data is being skewed towards negative values. If this whisker was higher than this one, was longer than this one, then my data is being skewed towards the higher values. What does skew towards higher or lower values mean? It just means you've got a few very big values compared to small, or a few very small compared to big. So that's why a box and whisker chart is useful. It's a visual way of describing the spread of a data set, and it's very useful if you're comparing two with each other, because then you can see how one compares to the other. Right, go ahead and complete all the tasks that go with this using this tutorial to create the graphs that you'll be asked to insert, as well as the calculations you have to do, and use the information sheet also to give you additional information on box and whisker graphs.